Hello everyone, I'm Miss Kanau again, one of your grade 11 maths teachers. In today's lesson, we would still look at logarithm. In our previous lessons, we looked at the properties of log, but in today's lesson, we would look at logarithm equation. What is an equation? We know what a logarithm is, but what is an equation? An equation is an algebraic expression that states that whatever it is on the left-hand side balances with whatever on the right-hand side. And it is equated with an equal sign. Let's look at logarithm equation and try to use the properties of log to help us solve or find the unknown. Let's look at example number 1. In example number 1, we have an expression that looks like this, or an equation, sorry. Log base 2, 16 is equal to an unknown value x. If log base 2, 16 is equal to x, then we think, oh, the only way maybe I could solve that is to express it in an exponential expression. So that would give me 2 raised to the power of x, because it's the base, that's the base there, is equal to 16. I look at 16 and I know that, oh, okay, 2, I'll put this properly so that it doesn't look like a 1. 2 to the power of x is equal to 16, and I know that 2 is a factor of 16, and 16 is a multiple of 2. So how many times am I going to multiply 2 by itself in order to give me 16? And the number of times determines the value of x. So that would give me 2 to the power of x is equal to 2 times 2 times 2 times 2, and that is equal to 16. So I could now say that it is 2 to the power of x is the same as having to say 2 to the power of 4. That simplifies, and the value of x is equal to 4. That is example number 1. Let's look at the second example. Example number 2. And in example number 2, we have an expression or equation, and it goes log base x. In this, we know the value that the base is 2. Unfortunately, this is an unknown, log base x. 27 is equal to 3. Log base x 27 is equal to 3. That simply means that we can express it in this form by having to say the base is x, and that is, the power is 3. The value is, or product is 27. Oh, okay. If that is 3, then we can find its opposite, which is the cubic. So that would give you to cube root of x cubed would equal to the cube root of 27. Remember, whatever you do on the left-hand side of the equation, you do on the right-hand side of the equation. So the cube root of x cubed actually is equal to 2x, and the cube root of 27 is equal to 3. So we can now say that the value of x is equal to 3. If you multiply 3 by itself 3 times, it gives you the 27. 3 times 3 is 9. Multiply 3 is 27. That gives us the example number 2. Let's look at example number 3. In example number 3, we have an equation, and the equation looks like this. 2 log base 4 is equal to log base 4 equals 9, or log base 4, 9. If that is correct, the base is 4, and this is the unknown x. 2 log base 4x is equal to log 4 base 4, 9. Now, how do we rewrite this to make it look easier? Okay, if that is correct, like the properties that we have learned, it says if that is the 2 before the log of the coefficient 2, we would have log base 4x to the power of 2 is equal to log base 4, 9. All right, that makes a bit of sense. I could simplify that, and I'm now left with x squared is equal to 9. Okay, 9 is a square number, x squared is a square number. So what do? I will have to balance it by having it x squared and square root of 9. Square root of x squared is x, and the square root of 9 is 3. So I would now know that the square root of x is 3, and the square root of 9, square root of x squared is x, and the square root of 9 is 3. And that gives me example number 3. I'd look at example number 4. And in example number 4, it would be a little bit funny, because this time you will have to think of quadratics and expressions that you have learned in grade 10. And the expression goes log base 2 parenthesis x squared, adding that onto 4x, all of that is equal to log base 2, 5. Let's simplify it. Log base 2x squared plus 4x to be written in a simpler form, because it has a common base, we are now left with x squared plus 4x is equal to 5. Let's simplify it further by grouping all the terms to the left-hand side of the equation. So that would give us to x squared, adding that onto 4x. You subtract 5x to both sides, so that would give me minus 5 is equal to minus 5 minus 5. Simplifying that would give me to x squared, adding that onto 4x, minus 5 remains, but this goes off and I'm left with 0. Simplifying that, we now have a quadratic equation. X squared plus 4x subtracting 5 is equal to 0. In quadratic equation, we need to factorize, and that would give us to that is equal to 0. X squared is actually x and x. The rule here is this: you have a minus 5 on the term, on the last term. And how do you get that minus 5? You find two factors, and the two factors of minus 5 would give you to negative 1 times a positive 5. That would give me to negative 5. And if I were to use the same factors, negative 1, and I add it to positive 5, it would give me to positive 4. Okay, I don't have to go any further because I've already got that. So I can now have my factors would be negative 1 and positive 5. So if negative 1 and positive 5, I can now find x subtracting 1 is equal to 0, and x is equal to negative 1 over there. So it gives me to positive 1 over here. And we have the second as x, adding that onto 5 is equal to 0. If it's a positive 5, we subtract 5 to both sides, and therefore x is equal to negative 5. I am now satisfied that I've got x is equal to positive 1 and x is equal to negative 5 as the value of the quadratic expression equation. That brings us to the end of our lesson. In our next lesson, we would still be on logarithm, but we would be looking at how we can use a table of values of logarithm and solving equations and its applications.